functions, notation, and evaluation. In this topic, we want to form a more sophisticated understanding of functions. To that end, we need to think more deeply about the statement, y is a function of x. As we consider this, we'll introduce a new notation called function notation, or f of x notation. So let's get started. Let's take a look at the equation y equals 3x squared plus 1. This is actually a relation. And moreover, this relation is actually a function. That's because for every input we have into this equation, for every x value we substitute into the equation, we get back one y value, an output. Thus, we say that the equation y equals 3x squared plus 1 defines y as a function of x. Let's take a closer look at what this means, y as a function of x. To do so, we want to substitute some specific values for x into the equation and find the corresponding values of y. A good way to organize this information would be in the form of a table, where the first column here represents our input, our domain values, and over here we have elements in our range. For instance, if I was to take -2, an element in our domain, and then apply the function to it, that is square -2 multiply by 3 and add 1, I'd get the corresponding output value of 13. Watch, we'll check. Y equals 3 times, and in place of x, let's substitute the element -2. Using the order of operations to simplify, we'd have 3 times -2 squared, which is 4. 3 times 4 is 12, because we multiply next. And finally, we add. 12 plus 1 is 13. Let's take -1. If we square it, multiply by 3 and add 1, we achieve 4 as our output. Likewise, substituting 0 in for x, we get y being 1. Substituting 1 in for x, we get y being 4, and substituting 2 in for x, we get y being 13 again. So now, considering the table above, what do you notice about the relationship between x and y? Well, hopefully it's clear that the variable quantity y is completely determined by the variable quantity x. And this means something in mathematics. We would say that y is dependent on x. This brings us to what we call function notation. When one dependent quantity is a function of another independent quantity, like when y is a function of x, the dependent quantity will usually be renamed f of x, written mathematically in the form f with the parentheses of x. Note, the notation f parentheses x does not mean f multiplied by x. Rather, f of x should be thought of as equivalent to the y variable. We say f of x, not f times x. More generally speaking, f of x is an abbreviation for any quantity that is dependent on x through the function f. One further note, the f in the expression f of x represents the name of a particular function, f. However, we can use any letter in place of f, such as g or h, or even the word umbrella. They all mean the same thing, y as a function of x. In our first example, we saw that the equation y equals 3x squared plus 1 defines y as a function of x. So, using function notation, we could rename the y quantity f of x, and then the equation would read f of x equals 3x squared plus 1. We could substitute instead and use a g, and then our equation would simply be g of x equals 3x squared plus 1. We could substitute in an h. We would have an equation h of x equals 3x squared plus 1. We could substitute in a letter p. P of x equals 3x squared plus 1. The possibilities are endless. In these equations, The expression f of x, g of x, h of x, and p of x are all representing the outputs of the function. They are simply replacing our letter y. And y is dependent on the input, x. So each of these equations is just another way to write the equation y equals 3x squared plus 1. The nice thing about function notation is it directly shows you a relationship between the dependent variable and the independent variable, the function of x. Let's take a closer look at function notation. One advantage to using function notation is when it comes to evaluating functions. Let's talk quickly about function evaluation. To evaluate a function at a given x value, we substitute that x value into the function and simplify. Now a quick note on function evaluation. The statement evaluate the function f at x equals a is written mathematically as find f of a. Let me explain a little farther. Let's recall our equation y equals 3x squared plus 1. We talked about how y is a function of x in this equation. And we can rewrite that equation using function notation. F of x equals 3x squared plus 1. Recall too that we set up a table of values for x and y. For instance, we had plugged in a value for x, -2. And when we substituted it into the equation, we got out the output y being 13. Do you recall that? Well, one way to represent the inputs and outputs is with function notation. And the way we would write it is we would say the function, when x is -2, is equal to 13. In this notation, -2 is our input, an element of our domain, and 13 is our output, an element in our range. It corresponds to the ordered pair -2, 13. Let's take a closer look now at function notation and evaluating functions with another example. As we mentioned previously, evaluating a function is the same as determining the y value that corresponds to a given x value. For instance, let's take the function f of x equal to 6x squared minus 10x. And let's find f of 3. What does it mean when we say find f of 3? Well, it means we want to evaluate the function of f at the x value of 3. And to do this, we substitute the value of 3 into the function everywhere where we see x. Let's rewrite our equation f of x equals 6x squared minus 10x, and we highlight the x values. Finding f of 3 means taking 3 as our element of the domain and inputting it into our function. We put it everywhere we see an x. This would give us 6 times 3 squared minus 10 times 3. And when we simplify this out, we get a y value, an output of 24. We would write our notation as f of 3 equals 24. 3 is our x value, and when we substitute that x value into our equation, we get the corresponding y value of 24. This means that for the function f of x equals 6x squared minus 10x, the x value of 3 must correspond to the y value of 24. Another way of saying that is that the point 3, 24 lies on the graph of the function f. Note functions can also be evaluated using only graphs. Let's do an example. Use the given graph of the function f to find f of 1. Now, to find f of 1 means to evaluate the function at x equals 1. In other words, we have to find the y value on the function that corresponds to the x value of 1. So how do we evaluate it using our graph? Well, again, f of 1 means to evaluate the function at x equals 1. So we start by identifying the location of x equals 1 on the x-axis. Now, where would the point be on the graph that corresponds to x equal 1? Notice it's this point here. This is the point on the graph where x is 1. And the y value that corresponds to that point is -4. X is our input, -4 is our output. It's the point that corresponds to this graph. So we would write our notation as f of 1, our input, equal to -4, our output. Or in other words, when x is 1, our x value is 1, our y value is -4. This means the point 1, -4, lies on our graph. Does that make sense? So let me quickly summarize the main ideas we've discussed. First, we looked at function notation. That is, we took an equation that was a function, y equals 3x squared plus 1, and we said we could rewrite this into function notation form, f of x equals 3x squared plus 1. And how do we do that? Well, we make sure our equation is first solved for the dependent quantity, usually y, and then we replace y with the abbreviation f of x. We also discussed function evaluation. To evaluate a function at x equals a, when a formula for the function is given, we simply substitute a for x. For instance, let's suppose we refer to our function and we substitute in the value 0 into our function. This simply means we take 0 and replace it into our function everywhere we see an x. This would give us 3 times 0 squared plus 1, which when we simplified equals 1. This tells us that f of 0 is equal to 1. And when graphs are involved, this further corresponds to the fact that 0, 1 lies on the graph of that function. 0 being our x value, 1 being our y value. When we want to evaluate a function at x equals a when the graph is given, we want to find the y value on that graph that corresponds to the x value of a. Let's now work several examples together where we take a deeper look at function notation and function evaluation.